limit at infinity question, and we're going to use it to talk about some key related concepts. So feel free to sit back, relax, review with me if you happen to be learning this, or you can totally just zone me out. That is perfectly okay. Close your eyes if you start to get sleepy. Get some nice good rest if you need it. But I do know that there are several friends here in our Math Nook who are taking calculus, whether it's the advanced placement version in high school or Calc 1 in college. And since it's the beginning of a semester, I thought we should go over this because, for context, this is usually taught at the end of a pre-calculus class, but calculus picks up where you leave off because the idea of a limit is very integral for the definition of a derivative. Get it? Integral calculus. So I just wanted to make that dorky joke, but I just want to make sure we're on the same page here, and this is just a kind of basic example, but I want to get started together and we can always come back and take a look at others as well. Okay, so definitely not a formal lesson or anything. I'm just here to hopefully help and encourage you. So, or relax you, or whatever would bless you. But this is what I'll be chatting about today. And in this case, when I talk about a limit at infinity, it's just taking the limit of a function and taking the variable, in this case x, to either positive infinity or negative infinity. So this is not to be confused with limits that happen to evaluate to equal infinity or negative infinity. These limits at infinity may be infinity or negative infinity, but it also might not be. It might actually be a constant or something. So in this case, this is the idea of end behavior. You might have heard that phrase as well, end behavior. And that's because when you graph different functions on the xy plane, they might have all kinds of different shapes and whatnot. But when you look at the end behavior, you're looking at what happens to the graph when the x values get really, really large, infinitely large. So does this thing curve back down and go towards negative infinity? Does it go to positive infinity? Or maybe it starts to approach a particular value. And same thing for negative infinity. As x gets really, really, really negative, what happens to the y values? Do they approach negative infinity? Do they approach a particular constant maybe? Or do they go off to infinity? So when we talk about end behavior, it's what happens when the x values get large or very small negative. So without getting too much into epsilon delta, which we don't have to do here, that's just our general idea of approaching. What does it look like? And when we graph points on our xy plane, x is our input, and so as x gets really large, y is our corresponding outputs for those inputs, and those outputs are determined by the function. So we have all kinds of different types of functions, but this is the function that we're looking at today. So this giant mess here is our f of x, the top over the bottom here. So that's what we mean by end behavior. That's what we mean by limits at infinity. So it's either positive infinity or negative infinity. Okay, very good. So for this particular exercise, I see that I have a rational function, so it's stuff over stuff. And I also notice that I have a polynomial over another polynomial. And why is it that I know that these are polynomials, or how do I know that? Well, I see that I have x's, so those are my variables, or that's my variable, and they are all on the base, and the x's are raised to whole numbers. So we have a 4, we have 2, this is a hidden 1, there's a 4 here, so no fractions, no negative numbers, just whole positive numbers. And this constant is just like having an x to the power of 0, because x to the 0 is 1, and that's just 8 there. So this is a polynomial, and this is a polynomial. So polynomials in general have terms where you have a constant, coefficient, times your variable in the base raised to some kind of whole positive exponent. So that's fine here. So I have a polynomial divided by polynomial. So that's just good to know in general. What kinds of functions are we dealing with? Are we dealing with exponentials where we have, the variable like 2 to the power of x, where the variable's in the exponent, or e to the x or something? Are we dealing with logs? Are we dealing with square roots here? What are we looking at? So here we have polynomial divided by a polynomial, which in itself here is not a polynomial like together. It's just 2 parts as a fraction. Okay, so before we get into actually calculating this, let's do what not to do. Okay, so this is where math goes completely wrong. And if there's one thing that I want to leave you with from this video, it's this. Just don't do this, okay? I'll make the mistake so that you don't have to. So, I see that there's this technique from pre-calc where when you're first doing a limit, if x approaches a constant, one of the first things they teach is to try to plug in that constant. So let's say x approaches 2 into your function. So anywhere you see x, just put in a 2. And if that thing gives you a number, that's your limit. We don't have to get into epsilon delta of why that is the case, but that's just a technique. If you get a number that works and it's not undefined or anything else, that is your limit. So I see here I have x approaching infinity. I'm going to just plug in infinity wherever I see x's. Okay, so 3 times infinity to the 4th. Well, infinity is really big. This thing goes to infinity. Okay, so that's infinity. Plus, if I plug infinity here, that's really big. I'm going to square that, so that's infinity. And then 7 times infinity. Well, infinity is infinitely big, so plus infinity. And then divided by 5 times infinity, so that's infinity. And then I don't really know what to do with the 8, but it looks like a sideways infinity, so I'll just leave it. Whatever. Okay, so let's see, I have infinity plus infinity plus infinity, so maybe that's 3 infinities divided by infinity minus 8. But if infinity is like infinitely large, the 8 is negligible. I remember something like that, so I'll just cancel that out. And so I get 3 infinity divided by infinity, which cancels, so that's 3. Okay, so there's no judgment if this is tempting, because it does make sense. It's a technique that we learn to plug in a number. The issue here is that infinity is not a number. It's not like a constant. It's not something that you can just add together, right? If you think about something being infinitely large, it would kind of make sense that, for instance here, 3x to the 4th, this x to the 4th power has more of a weight in the overall limit than, let's say, x squared, right? There's like a degree of largeness, so to speak, right? So how can we just do infinity plus infinity, right? What if it's like really big infinity plus a little bit less of infinity? So we can't exactly think think of things like this. We can't necessarily just add and divide infinity. So I guess I should have mentioned like infinity plus infinity or infinity minus infinity is an indeterminate form. And so is infinity over infinity. You can't just cancel that out necessarily to equal 1. And this is the same idea of indeterminate form for L'Hopital's rule if you happen to have already taken calculus. Ironically, you can actually use L'Hopital's rule to calculate this, but it doesn't make sense to learn about limits, to learn about the derivative, to learn about L'Hopital's rule, to then come back and do this question. It's a little circular there, but just as a heads up, this is an indeterminate form, and so whenever you're dealing with infinity, basically just don't be tempted to treat it like it's some kind of constant and to do your regular algebra with it. Instead, we are going to consider a couple of rules here for these polynomials. So if this were a quick exercise, let's say on the AP test or just a quick pop quiz or multiple choice question to see if you paid attention, all you have to do, okay, is to look at the term up here with the highest power, so the degree. In this case it's 4, so you take 3x to the 4th. Okay, so this equals the limit as x approaches infinity, and you want to order it from largest to smallest. And so if it's not written that way, you can rearrange it. But here we have 3x to the 4th, and on the bottom we have 5x to the 4th. And just copy those down. That's perfectly fine. But this is fine to write, okay? And we'll go into why. But if you're in a hurry or you're doing this for a quick question, that's all you have to do. Just take the highest degree terms if they're two polynomials. And now you just cancel out x4 and x to the 4th. You don't have to worry about 0 because x is approaching infinity. Now, I'm not contradicting myself when I say, you can't cross out infinity over infinity. Again, we're not plugging in infinity as an actual constant here. I am simply just canceling out whatever we put in here. So x is approaching a large number. It doesn't matter. It can cancel on the top and the bottom. It's not going to be 0. So we just get 3/5. That is our answer. And that is correct. So for this, it's just 3/5. You're basically comparing the degrees of the top polynomial and the bottom polynomial to see, does the numerator have more of a influence over our limit, or does the denominator? And in this case, they have the exact same degree, so we just have 3 and 5. So 3/5 is our limit. So for a multiple choice question where you don't have to show your work, that is perfectly fine. Most likely for a class, you will have to actually go through this exercise for homework or something, or maybe in a more open-ended question. So let's go through that actual process. But before we show our work here, let's highlight 2 key facts, which we actually already used here. The idea of considering only the limit of the largest degree for a polynomial is allowed. So that's just one little tip that we should remember. For polynomials, the limit as x approaches infinity or negative infinity, that's fine, of a polynomial which has the form an x to the n plus an minus 1 x to the n minus 1 plus a0 is going to equal the limit as x approaches infinity or negative infinity of just this highest degree, so an x to the n. So you're allowed to use this idea, and it's going to be even more clear when we actually go through the exercise of dividing out the highest power, but just keep that in mind. If you have an entire polynomial, and it has to be a polynomial, you can just take the limit of the highest degree the highest powered term. Then the other thing that we will be needing is if we have x to the n in the denominator and we have a constant on the top. And so the limit as x approaches infinity or negative infinity, so positive or negative infinity, of if you have like a constant on the top, and it's okay if it's positive or negative, of x to the n, where n is positive, and in this case we're still talking about, for now we're still talking about whole numbers, but we'll just have to look at that case by case. But in this case we have, actually it doesn't have to be a whole number, but we just want to be careful, but that this equals 0. So if we have some kind of constant, that's just the same. Like if we have a 3 in front, it doesn't change anything. So this can just be a constant. But if you think about like the base case of 1 over x, for instance, as x gets really, really big, infinitely big, this thing goes towards 0. It's taking, one whole and dividing it into infinitely many pieces. Each piece is going to get really small, right? Like 1 over 2 is just half, then maybe 1/10, 1/1000th, and then you get 1 over a bajillion, gazillion, bajillion, and that will just go towards 0. It will never be negative. If you're doing x approaches positive infinity, it'll never be negative. It'll just kind of start approaching 0. If you have a negative number, that's the same. It actually still also applies, and it is still 0, and it approaches 0, but it approaches it from the negative side here. So it'll approach like this. When x gets to be negative infinity or approaches negative infinity, it's 0, but all the values are negative as it approaches 0. So that's just a little fact that we can use here, and that we will need to use here when we show our actual work. So the little technique is to simply, so again, you can just do the 3/5, just apply this top and bottom polynomial thing and compare the highest degree terms if they're polynomials. But to actually show it, what we're going to do is basically divide by the largest power between all of the terms. So I look at all of these. We have 1, 2, 3, 4, 5 terms in this entire thing, and we divide by the highest power, in this case x to the 4th. And it's okay if we have 2 of them here, but we just note, like, among all of these, I see x to the 4th is the highest power of x. So I'm going to divide it on the top and the bottom, which is the same as like multiplying by 1 over x to the 4th on the top and the bottom, which cancel, right? Like I can multiply the top and the bottom by 5, and those 5s cancel. So we get something equivalent. So in this case, I'm basically going to divide by x to the 4th between all of these terms. So just make sure you understand why you're doing that and why that's allowed. But basically, yeah, you're just multiplying by 1 over x to the 4th on the top and on the bottom. So this is just a bunch of algebra here. Take your time if you need it. 3x to the 4th divided by x to the 4th is just 3 plus 2 over x squared. So x squared divided by x to the 4th. You can use your exponent rule. So it's x to the negative 2, which is the x squared goes on the bottom. But you can also just divide, like using fractions. So x divided by x to the 4th is going to be an x cubed down on the denominator. You have 5 here minus 8 over x to the 4th. Again, take your time with this algebra if you need it as a little roadmap. If you're struggling to actually divide through, that's more of an algebra issue than a conceptual issue, right? So no need to get too hard on yourself if you understand the concept of dividing by each thing by x to the 4th, but you're not getting an actual result. we can always go back and brush up on some algebra as well, right? Math always builds on itself. So I'm just here to kind of point out, instead of making it all one big mess, this is just algebra. So take your time with that. But all we're really looking at here is the fact that these are a bunch of fractions with x to the stuff on the denominator now. So those can actually go to 0. As x approaches infinity, these all go toward 0. So I'm left with 3/5. And that's the general idea here. When we show our work, we're essentially showing which terms go to 0 once we divide out that largest exponent of x. So in this case, we have x to the 4th on the top and the bottom. But if we had, like, let's say this is x to the 6th, we divide everything out by x to the 6th here, then this top part's all gonna go towards 0, which makes sense because the x to the 6th part has more weight on the entire limit. So in that case, it would go towards 0. If the top part has more weight and we have like an x to the 6th up here but an x to the 4th down here, then the whole numerator has more weight on the limit, and so the whole thing would go towards infinity as x goes to infinity. So you can kind of do this intuitively if you want, but if you show the work, you're always basically dividing by the largest exponent, the largest power of your variable x for this case. That's just one way to show your work. Do make sure that you're showing what you're dividing by. So essentially I would do this, and then I would make sure to say I'm going to multiply by 1/x to the 4th on the top and on the bottom, like so. And then you're basically distributing. That's what we're actually doing between all of the terms. So that's the algebra bit there. But in this particular case, it's 3/5, and that's simply because the two degrees are the same. So try out different scenarios where the powers are not the same and see if you can get some answers here. So if the bottom has a higher degree than the top, the whole thing is going to go to 0. If the top has a higher degree than the bottom, the whole thing's going to go to infinity or negative infinity. And if they're the same, then it's going to be a constant because those parts are going to cancel. And I think you should be good to go. Another little thing I do want to mention is that for infinity and negative infinity, just in general, this is just one type of like function, right? We can do others, like we said, we can do exponentials, we can do logs, we can do square roots and stuff. But when you're working with negative infinity in general, just do that algebraically. So consider, for instance, if you have x cubed and you're taking x approaching negative infinity, that's just x getting really, really small, but it's negative. So because this is an odd exponent, this is going to go towards negative infinity because -1 to an odd power is -1. So it's a negative, very large number. But if we have an even power, that's going to go to positive infinity because a negative number to raise to an even power is positive. So, all of our algebra facts still hold for this. And then we'll look at concrete examples for exponentials, or like where you have the x and the exponent. But in case you happen to be learning this before we get the chance to do so, consider if I have e to the x versus e to the negative x, just consider if you're taking x to negative infinity, here, like the negative will become positive, so this would take off and continue to positive infinity. But this would be e to some negative number, so that's 1 over something very large, which would approach 0. So all of these algebra things, concepts still apply. So That's the main difference between positive and negative infinity to consider is, are we talking about a positive value or a negative value for x, and does that even make a difference? So I hope that this is a helpful first little look. It's definitely not like a lecture, this was so scuffed, but I hope that we answered this question here. Again, if you're doing it very quickly, just go pop, those two are the largest, so we have 3/5. If they have different degrees, cancel out whichever one. If it's the top, like we would have 3/5x squared, and then the bottom would be weighted more, so then this would go to 0, etc. Just divide by the largest power. So pop 3/5, that would be like a very straightforward question. But if you have to show your work, make sure you show that you're dividing this all the way through, and rely on these two key facts here. Okay, so I hope that this was helpful. If you're asleep right now, I'm wishing you sweet mathy dreams. If you're continuing on with the rest of your day, I hope it's a good one. And don't forget, don't do this, okay? No plugging in infinity anymore. Take good care. I'll see you soon for more math and ASMR, or ASMR and math, as we feel like it. But thanks for tuning in with me today, and take good care. See you soon.